Right now, there is a ball of solid iron sitting at the center of this planet, about the size of the moon, spinning at its own independent speed. Completely detached from the ground you're standing on, it's hotter than the surface of the sun, and scientists just confirmed it's slowing down. So here's the question nobody wants to answer. What actually happens to us if it stops? From core to sky, let's dig into what's really keeping us alive down there. Alright, let's start with something most people have never really thought about. Right now, as you watch this, you're standing on a thin rocky shell wrapped around a planet that is essentially a layered onion of increasingly terrifying things. You've got the crust, that's us. The surface, where all the planets and oceans and cities live, and below that is the mantle, a slow-moving sludge of hot rock that takes millions of years to turn over. And below that is the outer core, a churning ocean of liquid iron and nickel, about 2,400 kilometers, which is about 1,500 miles thick. And at the very center, a solid metal ball that rotates independently of our spinning planet, like a top whirling around inside a bigger top, shrouded in mystery. That ball is the inner core, and it is absolutely wild. It has a radius of about 1,220 kilometers and sits at a depth of about 5,150 kilometers. Its temperature is approximately 5,200 Celsius, which is about 9,800 Fahrenheit. That is roughly the temperature of the surface of the sun. But here's where it gets weird. Despite that massive temperature, the inner core is solid. The pressure inside is nearly 3.6 million atmospheres. That's 3.6 million times stronger than the pressure at sea level. The pressure is so insane that even at sun surface temperatures, the iron simply cannot melt. It's literally squeezed into solid form against its will. So think of the inner core as a metal ball in a pressure cooker that's also on fire, and somehow it's spinning on its own, independently, like a planet within a planet. Now, about that spinning, here's something that actually made headlines recently, and a lot of people heard the news, panicked for about 10 minutes, and then forgot about it. New research suggested that the rotation of the Earth's inner core may have paused, and it could even go into reverse, actually. Scientists Yi Yang and Zhao Dongsong from Peking University of China studied seismic waves from earthquakes that have passed through the Earth's inner core along similar paths since the 1960s to infer how fast the inner core is spinning. What they found shocked them. Since 2009, seismic records, which previously changed over time, showed little difference, suggesting that the inner core rotation had paused. And then in 2024, another independent team came in and went, yeah, we checked, that's actually real. Research published in the journal Nature not only confirmed the core slowdown, it supported the proposal that this deceleration is part of decades-long pattern of slowing down and speeding up. Now, before you close your laptop and move underground, here's what that actually means. An independent geophysicist said the inner core doesn't come to a full stop, and that the finding means the inner core is now more in sync with the rest of the planet than a decade ago when it was spinning a bit faster. So it's more like your phone preventing you from using it when it gets really hot, slowing down to recalibrate, and not a full shutdown, basically. Based on seismic observations from 1964 through present period, the researchers believe the inner core goes through an approximately 70-decade oscillation. Basically, the inner core slows and then spins in the opposite direction roughly every 70 years. It's a natural cycle. It has probably happened before. It will probably happen again. But here's the wild part. What if it actually stopped? Like fully, completely, permanently stopped? What then? This is where things get genuinely unsettling. To understand why a spinning inner core matters, you first need to understand what it's connected to. And the answer is everything. The real engine of life on Earth isn't the sun. Well, it is, but bear with me here for a moment. The real shield that allows life to exist isn't the ozone layer. It's not even the atmosphere. It's a force field generated by the chaos happening in that liquid outer core surrounding the inner core. Earth's magnetic field is generated by electric currents due to the motion of convection currents of a mixture of molten iron and nickel in the Earth's outer core, a natural process called geodynamo. The inner core helps drive this. Earth's magnetic field yanks at the solid ball of hot metal, making it spin. At the same time, the gravity and flow of the liquid outer core and mantle drag at the core. Think of it like a giant power station underground. The solid inner core acts as the stabilizing anchor. Its rotation influences the flow of patterns in the liquid outer core above it, and those flow patterns generate the electric currents that become the magnetic field. It's all one interconnected system, and that magnetic field, it is the single most important reason you are alive right now. The Earth's magnetic field deflects most of the solar material sweeping towards us from our star at speeds of 1 million miles per hour or more. The sun is constantly firing a hurricane of charged particles at us, and the magnetic field is standing there like a bouncer at a very exclusive club going, "Not tonight, buddy." Here's how I want you to picture it. Imagine you're holding an umbrella in a storm. That umbrella is the magnetic field. The rain is the solar wind. Charged particles that would, without that umbrella, blast straight through our atmosphere. Now imagine someone slowly, quietly sneaking up and pulling the umbrella out of your hand. That's what happens if the inner core, and therefore the geodynamo, gives up. Now here's what actually unfolds step by step. Step 1. The magnetic field starts to weaken. The loss wouldn't be instant. It would probably take thousands of years for the magnetic field to significantly deteriorate, but the process would begin. And the first thing you'd notice? The auroras. Currently, auroras appear near the poles, following Earth's largely north-south magnetic field lines, but a weaker field would allow the particles to penetrate Earth's atmosphere, lighting up the sky closer to the equator. That part is actually beautiful. The terrifying part comes next. And this is where the real dominoes start falling. Now, before I continue further, I just want to say that I am a very anxious person, and I often think about things that are out of my control and let it get to my head, such as the Earth's core literally stopping and destroying literally everything we know. So if you're someone like that and would like to find a little bit of peace, I have found this program which actually helped me be a bit more calm and be okay with how things go, especially things that are out of my control. And if you would like to take a look at that, perhaps it could be something that helps you as well. I'll leave the link in the description as well as the pinned comment. Anyways, let's get back to the video. Step 2. Technology collapses. Satellites would be destroyed within days as radiation fries their electronics, cutting off GPS navigations, weather forecasting, and global communications. Every system that relies on satellite infrastructure, banking, internet, global shipping, military coordination, emergency service, all gone. Dunzo. Power grids would experience constant failures as charged particles induce massive electrical surges, similar to what happens during severe geomagnetic storms, but magnified thousands of times. We've seen a tiny preview of this kind of thing. Major solar storms in history have knocked out power grids in isolated regions. Now, a weakened magnetic field would mean that level of disruption becomes the permanent, everyday baseline, except way worse. Step 3. Radiation goes through the roof. Cosmic radiation hitting the Earth's surface would increase by at least 100 times its current level. To put that into perspective, astronauts on the International Space Station already experienced radiation doses 250 times higher than people on Earth's surface, and they're still partially protected by our magnetic field. And here is a space fact that genuinely rattled me when I first read it. While on lunar missions, astronauts often reported seeing flashes of light when they closed their eyes. The direct result of cosmic rays passing through their retinas. A few even developed cataracts years later. That's what happens beyond the magnetic shield. Even on a short trip, imagine living under those conditions permanently on Earth's surface. Step 4. The atmosphere begins to disappear. This is the slow apocalypse, and it's the most terrifying one because it's already happened to our neighbor. In its early infancy, up until around 4 billion years ago, Mars had a strong magnetic field, created just like Earth's, by convection currents of molten metals in its core. But unlike Earth, Mars cooled enough internally to switch off this mechanism, and the planet ended up with no global magnetic field. And once that happened, the solar wind stripped away most of the Martian atmosphere in only a few 100 million years after the planet lost its magnetic field. Since Mars lost its magnetic field 3.8 billion years ago, the pressure of its once Earth-like atmosphere has gradually reduced to just 1% of Earth's, letting through damaging UV light and cosmic radiation that make the surface a lot less habitable. Mars was probably once a lot like Earth, with oceans of water and thick atmospheres, but its magnetic field disappeared billions of years ago. Its atmosphere was left totally unprotected, causing it to be ripped away into space. Once its atmospheric pressure dropped low enough, its water began to evaporate until it too was taken by the solar winds. Mars is what Earth looks like after the core gives up. Now, is this imminent? Is this actually going to happen? Here's the reassuring part, and the part that should still keep you up at night. The short answer is probably not for a very, very long time. The current slowdown of the inner core is part of a natural oscillation cycle. According to the research, this slowing and reversing is a natural part of the core cycle. The last turning point was in the early 1970s. We survived that just fine. Okay. A slower spinning core would potentially affect the magnetic field and also fractionally shorten the length of a day, but we're talking microseconds, not hours. Nobody's going to notice. But here's the thing that should give you pause. Part of the trouble is that Earth's deep interior is impossible to observe or sample directly. Everything we know about the core, its rotation speed, its temperature, its composition, is inferred from seismic waves bouncing through the planet from earthquakes. We have never touched it. We have never seen it. It is impossible to directly observe the inner core. We are essentially listening to the planet's heartbeat from the outside and trying to figure out what's happening to the organ inside. And here is the philosophical bit, because I can't help myself. And you and I are standing on the crust, the thinnest, outermost layer, worrying about traffic and weather and what to have for dinner. Beneath us, 5,150 kilometers, which is about 3,200 miles straight down, there's a solid ball of iron as hot as the sun, spinning independently, generating a force field that lets us breathe, drink water, and not get cooked by a 1,000,000-mile-per-hour particle storm from the nearest star. The planet is not just a rock we live on, it's a machine, a precisely tuned, layered, interconnected system that has been running continuously for about 4.5 billion years. And the core is the engine room. The iron-rich core at the center of our planet has been a crucial part of Earth's evolution. The core not only powers the magnetic field which shields our atmosphere and oceans from solar radiation, it also influences plate tectonics which have continually reshaped the continents. Without it, there is no ocean, no sky, no breathable air, no you or I, baby. So next time you step outside and feel the breeze and look up at the blue sky, that blue sky exists because of something happening 5,000 kilometers beneath your feet, in a place we've never seen, in heat that would vaporize anything we could send down there. That's the core, and it's keeping you alive right now. Alright, that's going to do it for today's dive from literally the deepest place on Earth all the way up to the sky above your head. If this one melted your brain a little bit, good. That means it's working. Hit the subscribe button if you want more of this kind of thing, because on Core to Sky, we are absolutely not running out of wild stuff to cover. And I'll see you in the next one.